Okay, so hello and welcome to our video lecture for today. So this time we have the maxima minima. So maxima minima, ito yung application ng differential calculus. As I have discussed na yung calculus has a lot of functions with respect to changes in variables. Okay? So as for our learning objectives, of course, unang-una dapat makarelate tayo with the procedure in dealing with the maxima minima problems. So, not only the procedure itself, but also the key principle. And then secondly, illustrate a comprehensive diagram that describes conditions on the problems. Of course, we need to illustrate that and label so that we can figure out what will be the key variables and the key equations that we need to formulate. Okay? And then interpret maxima minima problem. So, hindi lang tayo magaling mag-solve, dapat magaling din tayo mag-interpret. And then, construct equations on maxima minima problems. So, when we construct equation, of course, that will be the basis. So, kapag nagkamali ka dito, everything will be incorrect. So, let us formulate equation with caution. Okay? And then, next, apply differentiation on maxima minima problems. Anyway, we are very much familiar with the differentiation process. Okay? So let us have now the principles. So maxima minima. Normally, the purpose of maxima minima in engineering is about optimization. So optimization can be facilitated by the principle of maxima minima. Say for example, on a certain coordinate system, we have a certain function of certain curve. The maximum and minimum values of a function can easily be calculated based from the concept that the minimum and maximum values has zero slope. So alam naman natin kung nasaan yung peak. Yung peak, either the highest point or the lowest point. Okay? So the peak has horizontal slope. Hence, dy over dx is equal to 0. Granting that this curve is in the function of x. So on the minimum side also, similarly, we have a zero slope. If a certain function of x is to be maximized or to be minimized, we will just have to differentiate that function with respect to a certain variable. Hence, we have f prime x. We just equate that to 0. So remember, differentiate mo lang yan sa isang variable and just equate it to 0. Because if we are going to recall, y prime is the slope of the curve. Hence, if it is horizontal, yung mga maximum tsaka minimum values nasa horizontal line. Therefore, we will have a principle dy over dx is equal to 0. Is a horizontal line. Okay? So with respect to the steps in dealing with the maximum minimum problems, first, of course, we need to identify ano ba yung variable na i-maximize mo or i-minimize mo. So example, area, perimeter, profit, and the like. Pangalawa, of course, there will be other conditions in the problem. So there will be a lot of variables here. But it is suggested that you must have to express the variable to be maximized or to be minimized in terms of a single function. Say, whether we choose x or we choose the function of y. Next, if the function shall consist of more than one variable, express it in terms of one variable using other available conditions in the problem. So, meron at merong other conditions that will be present in the problem that we could utilize so that we will not be dealing with a certain function na napakaraming variable. Dapat yung variable na i-maximize or minimize mo with respect to only a single variable. So that's the concept. And then of course, kung nagawa mo yun, all you have to do is to differentiate that variable with respect to the chosen variable. Okay? The chosen key variable. And then after which, we can now calculate the unknown. As an alternative, normally kasi, mas madali itong alternative in my experience. So first, we identify the variable. Just the same, we identify what is to be maximized or to be minimized. And then, mag-decide ka kung anong variable ang i-equate mo to represent that function to be maximized or to be minimized. Say for example, yung area mo could be expressed in x or y. Just decide kung i-differentiate mo ba yung area with respect to x or i-differentiate mo ba yung area with respect to y. So you have the choice. And then execute differentiation on equations with respect to the selected variable. So again, gagawin mo lang yung differentiation. So note that the maximized or minimized variable differentiated with respect to the selected variable is equal to 0. So yung slope niya is equal to 0. And then of course, we can now calculate what is unknown in the problem. So let us now try. Say for the number 1, the hypotenuse of a right triangle is 20 meters long. So meaning yung 20 meter long constant yan, Determine the perimeter that will make its area maximum. So we can proceed with the solution with the illustration first. First, we note that yung hypotenuse is hindi nagbabago. And then we delegate the changing value of x and y, wherein the area is to be maximized. So we have identified the variable to be maximized, which is the area. So we write the formula for that using the illustration. So area is equal to 1/2 x times y. And this function is to be maximized. Ngayon, mamimili ako between x and y. I will choose y. So I'm going to derive a with respect to y, in which that will be the slope where the slope is equal to 0. So dA over dy is equal to 0. At this point, we cannot proceed with the differentiation because we find two variables on the function of the area. So therefore, kukuha ko ng another relationship between x and y so that I can express x in terms of y. So we have ito Pythagorean theorem yan, 20 squared is equal to x squared plus y squared. So solving for x, we have that function so that we can substitute it on the formula. Notice now that isa na lang ng ating unknown sa area with respect to y na, Then we can now execute dA all over dy or d over dy on that full function. Okay, so the left hand side of the equation, we have dA over dy and then constant times product rule, So yung constant, iwan natin yung constant, 1/2. And then the formula for product rule is u dv plus v du. So u is square root of 20 squared minus y squared. Differential of y with respect to y is 1. Okay. And then v du, our v is y. And then we can write square root na raised to 1/2, That is why baba natin yung 1/2, bawas tayo ng isa sa 20 squared minus y squared ng isang exponent, it will become negative 1/2. And then differentiate the inner term. Okay. So, differentiate ng inner term, ano? Dapat kasali siya dito sa first line, no? Dapat meron siyang negative 2y because we differentiate 20 squared. 20 squared is actually 0 or a constant. So, ang differential ng y squared is negative 2y. So, by chain rule, kaya meron ditong negative 2y dito sa dulo ng equation. So, we equate that to 0. Then, we transpose the other term or the second term becomes negative, no? So, kung titingnan natin sa right hand of the equation, we can now cancel 2 there. Yes, 2 over 2 is 1. Okay, and then y would just be combined to y, becomes y squared. Ano? And then from that, tanggalin na natin yung negative. So, we're going to square all of the terms to eliminate radical. No? Kaya sa left-hand side, tanggal yung radical as well as the right-hand side. Only that, negative yung exponent mo sa right-hand side, yung 20 squared minus y squared. Negative 1 yan. So, bababa yan at the denominator. So, y squared is as well squared. That is why we come up with y raised to 4. With cross multiplication, ano? We'll have that value, 16,000 minus 800y squared plus y raised to 4 is equal to y raised to 4. Notice, na-cancel na yung y raised to 4. So, ang maiwan is 16,000 minus 800y squared is equal to 0. So, simplify and manipulate. Of course, divide both sides by negative 800, extract the square root. Then, we will have value of y is equal to square root of 20. And square root of 20 is actually 14.14. Ano? So, square root of 20 is 14.14. So, we need also to get the value of x. Kasi nga, we are after with the perimeter, no? So, pag sinubstitute mo yan sa function ng x a while ago, 14.14, we'll find out that x is also 14.14. And then perimeter is equal to x plus y plus 20. So, just add the values. We have 48.28 meters. So, ito yung y kanina. Y is equal to 14.14 meters. As an alternative solution, we have the same. Area is maximized, but this time, hindi ko na-express to in terms of a single variable. Diretso ko nang i-differentiate yan. Ngayon, with respect to x. So, I'm gonna choose x for that differentiation. So, all of the equations will be differentiated with respect to x. So, no need to express this area in terms of single variable. So, just execute differentiation with respect to x. So, if we do that, the left-hand side, we have dA over dx equal to 1/2. Product rule tayo, no? xy prime plus y. Okay? Notice, nagkaroon tayo ng y prime dito sa ating equation. So, dito na tayo gagamit ng other equation. So, before that, we note that dA over dx is equal to 0. So, as a relationship, kunin natin dito sa relationship ng Pythagorean theorem that 20 squared is equal to x squared plus y squared. And then, again, execute differentiation with respect to x. We have that value. And then, manipulate. We come up with y prime. So, kung may y prime na, we can now substitute in that equation. So, notice na na-eliminate na yung y prime. So, we have an x and y functions on a single equation. Therefore, magkakaroon tayo ng relationship between them. So, simplifying the equation, we come up with that equation and find out that x is equal to y. So, ngayon, kapag alam natin na x is equal to y, kunin lang natin yung relationship ng Pythagorean theorem, palitan mo yung isang variable, and then substitute, manipulate, and we come up with x value, which is also equal to y, which is equal to 14.14 meters. Then we are now ready to get the perimeter. So substitute the values and we have the perimeter equal to 48.28 meters. So that's it. So number 1, we have presented 2 alternate solutions for that problem. So it's really up to you kung saan ka komportable. Okay? So for the second problem, what is the area of the largest rectangle that can be inscribed in a semicircle of radius 10? So we have here a semicircle. So kailangan nating mag-inscribe ng isang rectangle. Of course, this rectangle has its radius equivalent to 10. So we need to indicate everything what is in the problem. Yun yung technique dito. So while you are interpreting, you are actually putting it in your illustration. So we're gonna label that. So why do we need to have 2 x's there? Because we formed 2 right triangles out of the rectangle that is inscribed relating to the radius. Okay, that is why pinaghati ko yung dimension ng horizontal ng dalawang rectangle. So why do we need to do that? Again, normally when we are dealing with problems, we need to simplify through forming a geometry that we know, and popular sa atin naman yung triangle. That is why the total area of that rectangle, yung rectangle tayo, so it's actually dalawang x times y. And note that this is to be maximized. And we choose y, differentiate area with respect to y, and equate it to 0. Then we execute differentiation of x for the whole function of area. And then again, product rule tayo with a constant. Magkakaroon tayo ng value ng y prime. So that, again, kuha tayo ng relationship from the Pythagorean theorem. 10 squared x squared plus y squared. Then differentiate that with respect to x. So differentiate the left hand constant is 0. So the right hand side would yield to that expression 2x plus 2y y prime. Dito makukuha natin yung y prime by transposing the other term to 2x to the other side. Then we find y prime is equal to negative x all over y. Substitute na natin dito. And then again, manipulate. Okay. So 2 here, mawawala na yung 2 because dividing both sides by 2 would yield to 0. Or 1 na lang sa right hand. 0 over 2 is 0. So tanggal na yung 0 dyan. And then here, transpose x squared all over y. Magiging positive na yan. And then again, x squared is equal to y squared. And then x is equal to y. Knowing that, substitute lang natin yung isang x dyan. Okay, manipulate, and then we find x and y dimensions which are equal to 7.07 units. So for the area, we have 2 times 7.07 times 7.07, we have actually 100 square units. So this is the largest area of the rectangle that can be inscribed in this semicircle having a radius of 10 units. Okay, moving on to the third problem. We have a rectangular field as an area of 10,000 square meters. What is the least amount of fencing meters to enclose it? So basically, we need to draw a rectangle with 10,000 square meter. We're gonna label X and Y so that its area is X and Y. So 10,000 is equal to X times Y. And the perimeter is equal to 2X plus 2Y. And note that the perimeter should be minimized. Hence, we choose X. Differential of P with respect to X is equal to 0. We execute d over dx to the first equation. We come up with that 0 is equal to xy prime plus y. Again, meron tayong y prime dyan. Okay. And then, do it also for perimeter. So we have 0. So yung perimeter na maximize dp over dx yan, ano, sa left hand side. And then differential of 2x is 2. Then 2y prime for the second term. Then y prime is equal to negative 1. No? And then from that, we can now substitute negative 1, okay, and find out that x is equal to y. Okay? By the way, just neglect 2 here. Dito sa equation na to. No? Itong equation na to, itong pangalawa na to, neglect 2 there. Okay? Anyway, it will be just cancelled, ano? Tatanggal din naman yan. And then, we come up with x is equal to y. And then here, the relationship, alam na natin na x is equal to y. Just have to replace y with x. And then, we come up with the value of x, which is equal to y, equal to 100. No? So, kung alam natin yan, we just have to substitute it on the perimeter equation. Therefore, this is the least amount of fencing meters to enclose it. It refers to the perimeter at the minimum value of x and y. Okay? So, that's it. So, number 4, we have the sum of the lengths of all edges of a closed rectangular box is equal to 6 meters. If the top and bottom are equal squares, what height in meters will give the maximum volume? So we refer actually to a cube. Itong cube na to, square yung top niya. So therefore, square. We delegate a dimension which are equal, x. At yung height is y. Therefore, the volume is x squared times y. And this is to be maximized. Note that dv over dx is equal to 0. Notice, nang pinili ko dito is yung x with respect to x. So, all in terms of x, we derive the first equation. dv over dx is equal to x squared y prime. Ito, product rule yan. We came up with an expression with y prime again. Yan na. And equate it to 0. Of course, we need to use another condition in the problem. So, ano kayang another condition yon? Kung titignan natin sinabi dito, the sum of the lengths of all edges, lahat daw ng edges, would equate to 6 meters. Ano ba yung edges nito? So, meron tayong 4 sa baba na x, 4 sa taas na x. So, all in all, may 8 x. At sa y, all in all, may 4 na y. So, 8 x at 4 na y would equate to 6 meters. So, that is the condition in the problem. So, differentiating that whole equation with respect to x, we can manipulate and come up with the value of y prime equivalent to negative 2. So, knowing that, substitute na natin siya dito. Okay. So, negative 2 yung y prime. So, manipulate, again, cancel yung isang x. So, again, x is equal to y. No? So, from that, we can use this function to solve for the dimensions. Palitan mo lang yung x ng y, total equal naman sila. Then, we come up with x is equal to y, which is 6 all over 12, or that is 1/2. Okay, so di ba napakadali lang, no? So, number 5, a printed page must contain 60 square meter of printed material. There are to be margins of 5 cm on either side and margins of 3 cm on top and bottom. How long should the printed lines be in order to minimize the amount of paper used? So, ito yung paper use, which is to be maximized. Take note of that. The condition is that dapat meron siyang margin on both sides na 5 cm at meron siyang top and bottom margin of 3 cm at ito yung printed portion na dapat 60 square meters. So, ilan dapat yung printed lines? So horizontal printed lines is x and vertical printed lines, I'll delegate it as y, so that the total area is the horizontal dimension times the vertical dimension. The horizontal dimension is x plus 10 and the vertical is y plus 6. And that is to be maximized. I'm going to choose y here. But before that, we need to obtain another equation because we find from the area na dalawa yung variable x and y in terms of the area. So, we're going to use the printed area, which is 60 square meter, which equates to x times y. So, we can express x in terms of y, which is x is equal to 60 all over y. We substitute on that equation. Okay, so all in all na lahat, y na, no? Wala nang x. So, differentiate or simplify muna natin yung first term, Get the denominator, okay? And then execute d over dy. So, with that, this is actually a product rule. UDV plus VDU. Equate that to 0. And then, kunin mo lang yung LCD. Anong LCD nitong dalawang term? Y squared. And then, simplify the numerator. We find that y is equal to 6. So, kung alam natin yung y is equal to 6, ang relationship ng x to y is 60 all over y, wherein 60 all over 6 is actually x is equal to 10. So, ganun lang. We have found the unknown x is equal to 10 and y is equal to 6. So moving on to the 6th problem, we have here the cylindrical boilers to have a volume of 1,340 cubic feet. The cost of the metal sheets to make the boiler should be at minimum. What should be its base diameter in feet? So here, meron tayong cylindrical boiler having a radius and the height In order to minimize the material to be used, we minimize the surface area kasi yun yung binabalot natin, yung surface area. At yung surface area is actually a combination of two circles on top and bottom, ano? Kaya kung titignan natin, so first term is 2 pi r squared, and then we're gonna add yung horizontal na takip ng sides, which is the circumference times height. Okay, so yung circumference is 2 pi r. No? Kapag binuklat mo yan, parang rectangle lang yan. No? At yung length niyan is actually 2 pi r because it circulates on the circumference on the circle. That is why the second term is 2 pi r times h. Note that surface area is to be minimized this time. So, I'm gonna choose the radius as my function to derive the area. And then the volume should hold here 1,340. So, by the way, we need another function because you can find the surface to the surface area na may h pa yan. Kaya ginamit ko yung volume. Anyway, dapat yung volume condition na it must hold 1,340, no? So, and the formula for volume is pi r squared h. So, we just substitute the required volume and then express h in terms of r. Then, 1,340 over pi r squared. We substitute on that equation. Yan na. And then, maka-cancel na yung pi r, ano, yung 2 magmumultiply sa 1,340, magiging 2,680 sa second term. And then, get the LCD, differentiate with respect to r. So, this time we have quotient rule, v du minus u dv all over v squared. Okay, so we just execute. V is r, du, or the differential of the numerator, is 2 times 3, that is 6. Then copy pi r squared, bawas tayo ng isa sa isang radius. And then minus u dv, just copy all of the terms, and then differential of r is 1 all over v squared. That equates to r squared. So, r squared, again, dito, magko-cross multiply lang yan sa 0. And then, by manipulation, yan na. Ninipis na hanggang makuha na natin yung r. And then, we extract the cube root of r so that r will be equal to 5.97 feet. Ang unknown dito is the diameter. So, we'll just have to multiply it by 2 to make it a diameter, no? So, we have 11.94 feet. So, as easy as that. Okay. So, let us move on to another problem. So, this time, sa economics naman tayo, we're gonna have a problem regarding business operations. So, we have a manufacturer can produce a commodity at a cost of 2 peso per unit. So, ibig sabihin, ito na yung production cost niya, no? 2 pesos per unit. So, binibenta niya to at 5 pesos each. Consumers have been buying 4,000 pieces a month. So, ito yung regular na kanyang nabibenta a month without increase pa, no? Ngayon, it was observed na kapag nagpataas siya ng piso increase in the price, bumababa yung benta niya by 400. Okay? So, halimbawa, nagpataas siya from 5 pesos to 6 pesos. Imbis na 4,000 ang nabibenta niya, we have 3,600 na lang kasi naibawas yung 400. In every piso, 400 yung nababawas sa benta niya. a month. That is the observation. So, mathematically, we can maximize the profit by maxima minima. So, at what price a piece will the total profit be maximized? So, first, we should have to delegate variables here. Let x is equal to increase in the price. So, ngayon, we consider an increase in the price. So, meaning, yung selling price mo, hindi na 5 pesos. So, yung selling price mo maging 5 plus x. And then, let P the profit. Remember that the profit is equal to sales less expenses. And this is to be maximized. Okay, we choose x because x is the increase in price. Wala namang iba. And then sales is actually the selling price times the unit sold. Anong selling price? Hindi 5 pesos. Kasi we're going to consider an increase in price. Kaya, yung selling price mo supposedly is 5 plus x times unit sold. So, sa expenses naman, production cost times unit sold. Yung production mo, sabi natin, is 2 pesos times unit sold. Ano ba yung unit sold? Is actually equal to 4,000 minus 400x. Saan nanggaling yan? Dun sa condition. So, sa data mo, sa forecast mo. Na kapag nag-increase ka, in every piso, nababawas yung 400 units na benta. Okay, from this, we can just substitute all of the equations. Yung sales mo is 5 plus x times 4,000 minus 400x. At yung production cost or the expenses is equal to 2 pesos times 4,000 minus 400x. And that is to be subtracted from the sales. Okay. Of course, all we have to do is to simplify. Anong ginawa ko dito? 4,000 minus 400x is actually common to the first and second term. That is why I'm gonna factor that out. Ang naiwan is 5 plus x minus 2. Then we execute differentiation with respect to x. Meron na tayong product rule dito, no? So, equate that to 0. Product rule tayo, that will be our equation, udv plus vdu. Then, just manipulate, we can find x equal to 3 pesos and 50 centavos. So that the new selling price is 5 plus x. 5 plus 3.5 is 850. So, ito na yung price na yung profit mo is to be maximized. Okay. Ganda, no? Next. Number 8. The sum of two numbers is 8. Find the minimum value of the sum of their squares. So, ito, gagamitin natin yung talent natin na mag-interpret. Of course, first, we need to delegate variables. Let x the first number at yung y yung other number so that yung sum nila is 8. Diba? X plus y is equal to 8. So, that is the first condition. And then, the sum of their squares, let us say that is s, is equal to x squared plus y squared. And this is to be minimized. So that ds over dx is equal to 0. Of course, we can simplify that y, from the first expression, we can find that y is equal to 8 minus x. Nang sa ganun, masubstitute natin yan dun sa s equation. So, notice, x na lang ang meron sa s. So, it's now ready to be differentiated with respect to x. Okay. So, by manipulation and differentiation, 0 na yung left hand, no? So, the first term is x squared or 2x. Differential of x squared is 2x. And then, ito, power formula again, bring down 2. 8 minus x, subtract 1 from that, and then differentiate the inner term. Remember yung chain rule, That is very important. Differentiate 8 minus x, that is negative 1. So by that, we can simplify the equation, combine terms, and manipulate x is equal to 4. So knowing x is equal to 4, makukuha na rin natin yung y with that relationship. So 8 minus x is y. So 8 minus 4 is y. That is also equal to 4. So makukuha na natin yung unknown. Okay, the sum of their squares is equal to x squared plus y squared. We have s is equal to 32. Okay, so I think that ends our lecture for today. So the key here is for you to practice. So thank you for listening and have a good day, class.